Hi everybody, we're back again for our second day of new types of factoring, which is super exciting. So for today we are looking at 4 terms instead of just 2 or 3, so it's factor by grouping. For whatever reason, this always seems to be everyone's favorite way to factor. I think people pick it up usually the fastest. It is pretty quick, pretty easy. If you can pull out a GCF, then you're able to factor by this method. So kind of break it down step by step for you. This is when we have 4 terms. All right, so we're going to have 4 terms. What we're going to do is we're going to group the first 2 together in parentheses, group the last 2 together in parentheses. You will factor out a GCF from both groups that you created. Then what's going to happen is you should have a common factor. You will factor that out, and then whatever's left over will be the second set. The mistake most people make on this is a lot of times they won't keep going. They'll group them and factor out a GCF, and then they stop for whatever reason. So let's go ahead and go through this, and I'll kind of talk you through as we go. So first problem, notice again on number 13 here, we have 4 terms. So for grouping, we are going to group the first 2 together and the last 2 together. We will take out a GCF. So from the first set, I can take out an x squared. That will leave us with 2x plus 1. Don't forget that 1 there, right? We need to have something kind of as a placeholder so that if you were to distribute back in, right? If I was going to take this x squared, I could distribute back into both parts and get what you started. So if you don't put this 1 here, then we end up with a missing piece. All right, from the second set, we can factor out a -9. Remember, anytime that you are looking at factoring, if that first term is negative, we want to take that out. So taking out a -9, right, that's like dividing both of these by -9, would leave us with a positive 2x and a positive 1. All right, we are not done factoring, and that's where most people, if you're going to mess up somewhere, it's going to be right there. We're not done. All right, we have to keep going. So if it factors by grouping, which in this section they all will because that's what we're learning, what you should notice is you have 2 parentheses, like that leftover stuff after you factored out your GCFs. They should be the same. So what we're doing in essence is we are factoring out the GCF, or factoring out the GCF now is that common piece. So what we're doing then, factoring out a 2x plus 1. It's like you're factoring out a GCF from the entire piece of your puzzle. So factoring that out, right, like if you would divide both parts by that 2x plus 1, taking out that GCF, right, that would cancel out. All you're left with is x squared minus, factored out of this one, and you have x squared minus 9. Now the other way to think about that is I've kind of labeled that as this is your common factor. There we go, common factor. And then this stuff is the leftovers. Sorry, still getting used to writing on this board. Here we go. So again, the common factor, that was the part that was common to both of them. That's what comes out in front. And then you had your leftover stuff, x squared minus 9. That's your leftovers. Now, hopefully you're looking at this going, but Miss Olner, we're not done factoring yet. You guys see this difference of squares that just showed up? So even sometimes you think you're done, you always have to look at what you have. I have 2 terms with a minus sign, and they're both perfect squares. So that will factor further into an x plus 3 and x minus 3. And then this part just going to come down to x plus 1. So this is fully factored. Now, the answer I had right here, that was my answer. That's factor by grouping. That looks great. But I just had to notice I did have a difference of squares, which I then had to factor a little further. Okay, let's try another one because that one got really kind of crazy halfway through that problem. All right, so number 14. Again, let's take a look. We have 4 terms. We will group the first 2 and the last 2, and then we pull out a GCF. So the GCF in that first set, I can take out a 2x cubed. So taking out 2x cubed from here leaves me with x minus 2. All right, then we will pull a GCF out of this second part, and the first one's negative, so I can take out a negative 10x. Taking out negative 10x, we're left with a positive x, and then negative 2. All right, that is your first steps of factor by grouping. Do not stop, we are not done. Factoring out a common factor again, my common factor is x minus 2, and then left over is 2x cubed minus 10x. So there it is, factored by grouping. Now, always do that check. Will it factor a little further? And if you notice, this piece right here actually has a GCF still sitting inside there. So I'm going to pull out my GCF. I can take a 2x from that. Leaves me with x squared minus 5. And this guy, I'm just going to kind of bring him down, x minus 2. Now, I still need to look to make sure that this is not a difference of squares, but since that's a 5, that's not a difference of squares. So this is fully factored. All right. Now, some people get themselves caught up and they're like, but wait a minute, what happened? Why did you have 2x minus 2's, way up in here, but you don't have 2 of them down at the bottom in your answer? Like, where did one of them go? So just kind of reiterate where all these are going. Let's just kind of bring this piece down here for a minute. Just kind of a further explanation. If I call this 2x cubed, and instead of x minus 2, what if I call that y? I put that a y there. Minus 10x, and again, instead of this x minus 2, I call that y. All right, I'm just, calling it something else so it's something that you can understand a little better. Because then if I did that, looking at this problem, I'd be like, well, I can take a y out, left with 2x cubed minus 10x, which is exactly what I was doing, except instead of a y, well, that was my x minus 2, right? So y is not really there. So you got to think of that parenthesis of x minus 2, it's just like one more piece. It's like you're just always pulling out that common piece out in front, pulling out a GCF. So yeah, it shows up in both parts, but when I pull out in front, I just have the one of them, not 2. All right, hopefully that didn't confuse you even more so. But let's try another one, seeing how we're doing. All right, so number 15. I'm going to group the first 2, group the last 2. All right, so I had my 4 terms, group them, GCF in the first set. I can take out a 4x squared. I'm left with x plus 3. GCF in the second part, there's really no number that goes in there, but we have to take out something. So even if nothing at all whatsoever, nothing goes into it, take out a 1. In this case, I'll do -1 since the first one's negative. But if you have to write +1, then write a +1 because we have to have something. But taking out that negative, we'll change that to a positive x plus 3. All right, hopefully you're looking and going, hey, look, there's a common factor. Yeah, that common factor, we'll factor that out as x plus 3. And when I factor that out, I am left with 4x squared minus 1. That's my leftovers, right? Common factor right there. And this is my leftovers. Anybody see anything? Yeah, we got to keep going. That's a difference of squares. So that's going to factor to 2x plus 1 and 2x minus 1. And then he just kind of comes down as x plus 3. And we are fully factored. So before you're finished factoring ever, do your steps, do what you think you got to do. Look at your final answer. make sure if you have like an x squared left over, do you have a difference of squares sitting there? So always kind of keep looking. Is there a GCF, something else I can do? Sometimes you can, sometimes you can't, but you just need to start being able to look at that and recognize what you have left over. All right, number 16. Again, I see 4 terms, so right away I'm going to do grouping. Group the first 2 and group the last 2. Oops, sorry about that. All right, so doing my grouping here, we can take out a GCF from each one. So from the first one, I can take out an x. So I'm left with z minus 2. From the second set, I'll take out a negative y. It'll leave me with a positive z minus 2. All right. Once you've taken out GCFs from both, let's take out the GCF factor here, which would be z minus 2. And we'd be left with x minus y. All right, I think I'm good. Taking a look, I don't see any squared terms left to look for difference of squares. I don't see any GCF still sitting anywhere. So I am finished. All right, that is factor by grouping. The next type of factoring we're going to look at is the sum and difference of cubes. So I've talked to you before. I know my favorite type of factoring is, of course, difference of squares. They're easy, they're fast. I also do like the sum and difference of cubes. Sum and difference of cubes is one of those where you just have to memorize the pattern. It's not like you're going to do a guess and check like we can do with most factoring. It's either you know the pattern or you don't. So first, let's talk about how do you recognize them. So first, what are cubes? Sum and difference of cubes. Sum and difference means I'm adding or subtracting cubes. So you know your perfect squares, right? Like 2 squared, 3 squared, 4 squared. So same idea with cubes. I don't think in these numbers, we typically don't recognize them as much. So 1 cubed, 1 times 1 times 1 is 1. 2 cubed, 2 times 2 times 2 is 8. 3 cubed, 3 times 3 times 3 is 27. 4 cubed, 4 times 4 times 4, 64. 5 cubed, which is 5 times 5 times 5, which is 125. 6 cubed, which is 6 times 6 times 6, is 216. 7 cubed would be 343. 8 cubed is 512. And 9 cubed, 729. And 10 cubed is 1,000. Now, do you have to memorize those? No, absolutely not. We have a calculator in our hands at all times anyway. I just wanted you to see the list. Sometimes it helps to have it in front of you so that you recognize it. Otherwise, you're just going to have to kind of keep practicing and seeing if you can figure out how to do that. Okay? If you have your graphing calculators out, kind of checking because you have to do cubed roots, kind of working on backwards. So on the graphing calculators, you'd want to hit your math button. Going from memory here because I actually do not have mine in front of me. The math button, and then I believe it's option 4, I believe. Looking for the cubed root button. It looks like that. But it's underneath the math menu. So you have to hit the math button first and then look for the cubed root. Okay? All right. So my favorite factoring is difference of squares, which has to be a minus sign with 2 terms and both perfect squares. Now, sum and difference of cubes means it could be a plus sign or it could be a minus sign. So it doesn't matter. Either one. You can add or subtract. The other thing that I love about this, you guys know what a germaphobe I am, especially this time with everything going on. But you have to remember to use SOAP. That's how we remember what the signs are, okay? So SOAP stands for same sign, opposite sign. That one should not be white. Sorry about that. So same sign, the O is opposite sign, and then the AP stands for always positive. So if you look up here at the top, it's going to have this original problem had a plus sign in it. So when you factor, the factored answer should have the same sign, right? These are the same. And then flip it to the opposite sign. It was a plus, switch to a minus. And this one's always positive, no matter what. So looking at the other one, this one had a minus in the original problem. So the first sign is the same, exactly the same. And then it switches to the opposite sign, was minus, flip to a plus. And then this one is always positive, no matter what. Okay. So now let's look and see how these factor. Again, this is not something you are going to guess and check and play around with the numbers. You either memorize the pattern or you don't. Okay? So kind of looking here, if my original problem, they both have to be perfect cubes. So a lot of times you'll have like x cubed plus 27, you know, whatever it might be. But it's just going to be two things that are perfectly cubed. When you set this up, your two sets of parentheses, notice the second set of parentheses is longer. It's got 3 terms, and the first one only has 2. This is very different from anything we've ever factored. Okay, so the very first ones, you take the cubed root of that first term, right? So it is written down here at the bottom so you can see it. But we do the cubed root of the first term, and that's what goes here. So as I'm kind of working through here, let me kind of give you another example. If the problem was x cubed plus 27, so I would set up my parentheses. I would make sure I use SOAP, so the same sign would go here, same, and then it would flip to its opposite. Opposite of plus is a minus, and then this sign is always positive. That's a plus. Okay, so we just said it has to be the cubed root of each part. So the cubed root of x cubed is x, and then the cubed root of 27 is 3. So you just do the cubed roots. Okay, that's what this is showing you right here. Now, after I do that, my original problem, I really don't care about anymore. I've used it as far as I need to use it. Moving forward to the second set of parentheses, you will square your first number, right? See how it's a squared? So whatever that first number was, you square it and put it right here. Well, all right, my number was x. What's x squared? Well, it's easy. That's x squared. All right, the next part is you multiply. It says a times b. Well, that's the two numbers that are over here. So what's x times 3? Well, that's 3x. And then the last one says you square. It's b squared. Well, b was that last term. So what's 3 squared? That is 9. Now, it looks like this second part will factor further right here. It looks like you're like, hey, yeah, that's a, quadratic. I should try to factor that further. I'm going to tell you right now, it won't. It will never factor further. Ever. It will not factor further. If I was in class with you guys right now and I would call you all out by name and ask you, is that going to factor further? Will that factor further? Will that factor further? I will call you all out by name. Now, granted, I'm doing this on a video to teach many, many students right now. I will not do that. However, will that factor further? The answer is no. If we try, just for giggles right now, if we would try, I want to show you. All right, your last one is positive, so they're the same, so they'd be both minus. Option for A would be x and x. Options for C is either 1 and 9 or 3 and 3. Well, if I go 1 and 9, negative 1x minus 9x, that doesn't make negative 3x. Okay, so let's say, well, that didn't work. What if I tried my other numbers? It's got to be the other way then, right? Okay, so let's say I put 3 and 3. Well, that's going to give me negative 3x minus 3x, which is negative 6x. Still doesn't work. So will it factor further? No, it's not going to factor further. Don't try. Don't waste your time. It never will, I promise you. It will not factor further. So right here then, is factored answer. So let's go ahead and try another one. All right. So we have 27x cubed minus 8. So as always with all factoring, do you have a GCF? And the answer is no. Nothing goes into 27 and 8. So I've talked to you in the last video that we need to start recognizing our factoring. So when I look at this problem and there's no GCF, I see two terms with an x cubed. That's kind of a big red flag. Two terms and an x cubed. It's probably sum and difference of cubes, right? 27, if I take the cubed root of 27, is it perfect? Cubed root of 8, is that perfect? The answer is yes, it is. So this is one that we will set up using SOAP. So set up your parenthesis. The second parenthesis is always a little bit longer than the first one. SOAP, again, is your signs. So it is the same as the original problem. So that's a minus. Then it switches to the opposite. The opposite of minus is plus. And then the last one is always positive. So there's your signs. Always start with that. Because if I fill those in to start with, then I don't got to worry about another sign the whole problem through. I already put them in. All right, so from here, the next thing we need to do is we need to follow the pattern. Again, you cannot just guess and check this. You have to memorize the pattern. So the pattern is we take the cubed root of both of these. Cubed root of 27x cubed is 3x. That's a terrible 3. Sorry about that. Let's try that again. That's better. That's 3x. And the cubed root of 8 is 2. All right. Moving on to the next part, it is always square, multiply, square. Square, multiply, square. However you want to remember that. So you will square the first one. So what's 3x times 3x? Right? That would give you 9x squared. And then you multiply the two together. 3x times 2. Not worried about the sign because I already filled them in. 3x times 2 is 6x. And then you square the last one. 2 times 2 is 4. Hey, will that factor further? You better have just yelled no at whatever you're watching this on. It will not factor further. Do not try. Do not waste your time. We're going to stop right there. It will not factor further, no matter it looks like it will. I promise you it won't, okay? Do not factor any further. All right, number 18. So I'm looking at this problem. My directions will say to factor. So you have to recognize it. So I'm seeing, okay, first thing, take out a GCF. Nothing goes into both. Okay, so what I have left is two terms, and I have an x cubed. All right, it means it's probably sum and difference of cubes. Can I take the cubed root of 125? Yes. Can I take the cubed root of 1? Yes. So that is my sum and difference of cubes. So set up your parentheses. Second set is always a little longer. We will fill in our signs with SOAP. So same sign starts it. Then it flips to the opposite. Opposite of a minus is a plus. And the last one is always positive. All right. Then it is a matter of, did you memorize the pattern? So we take the cubed root of 125x cubed is just 5x. You will take the cubed root of 1, which is 1. And then you will square, multiply, square. So 5x squared, meaning 5x times 5x is 25x squared. Multiply the two together. 5x times 1 is 5x. Again, I put the signs in right at the beginning, so I don't have to worry about them now. And then square the last one. 1 times 1 is 1. Will that factor any further? No, it won't factor further. I am done. Isn't that nice? I don't even have to look at it. I know it won't factor further. All right, almost done, guys. Number 19. Is there a GCF there? And no. If there is one, you just take it out like normal and proceed like you always do. Just baby brother tagging along. But there isn't one. So we'll go ahead and set up our parentheses. I recognize I have two terms with a cube. I will use SOAP to fill in my signs. So the same sign starts it. Flip it to its opposite, and then the last one is always positive. All right. Then the pattern, because that's the only way to do these, we take the cubed root, which is 2x, and the cubed root of 1 is 1. All right, fill in the other part. It is square multiply square. First term, 2x times 2x, right? We're squaring it. Gives me 4x squared. You multiply these two together. 2x times 1 is 2x. And then square this last one. 1 squared is 1. And no, it will not factor further. I am done factoring. All right, last one. We're almost there. All right. I recognize two terms. Doesn't matter if it's a plus or minus because I have an x cubed and they are perfect cube numbers. Two sets of parentheses. Second parenthesis a little bit bigger. We will use SOAP to fill in our signs first. So same sign starts us off, flips to the opposite, and then always positive. Then from there, all we have to do is follow the pattern. Have to memorize that pattern. All right, what is we take the cubed root of x cubed, which is x. The cubed root of 343 is, what is that, 7? Yes, 7. Sorry. All right, so I don't need my problem anymore, right? I'm just going to go on to my pattern, which is then square, multiply, square. Square the first one. X times x is x squared. Multiply the two together. X times 7 is 7x. And then square this last one. 7 times 7 is 49. And that will not factor any further. That is my factored answer. All right. Hopefully that made some sense to you guys. If you have questions, feel free to reach out. You can always rewatch the video again. Stay tuned looking at Google Classroom. Kind of keep working through your lessons for the week. You can work at your own pace. Feel free to reach out during our video chats that we have set up. Otherwise, message me. I'll get back to you guys. Whatever you need, I'm here to help, okay? There's also IXLs that will be posted that you can work on those. They are not required. IXL is not for a grade, but sometimes you just need more problems just to practice. And if that's what you need, it's there for you. Just look on the posting and it will be listed there so you can find that. But good luck, guys. Take your time working through it all. I would do the homework assignment I gave you first. Check your answers. When you are done and ready, you will take your lesson quiz on Quiz-Iz, which is the part that is for a grade with one attempt. Okay, so make sure you do your best. Actually, I scratched that. Not one attempt. I changed that. We need to make sure you get the recommended 80%. So you can take it as many times as you need to get the 80%. That will allow it to be as completed then in the grade book. All right, guys, if you need anything, don't ever hesitate to reach out. All right, we'll get through this together. Thanks, guys.